welcome back to geometry. So if we think back to some of the things we learned in quadrilaterals and some of the things we learned in trigonometry, we can actually find the area of these shapes fairly easily. So a square is also a rhombus, and a rhombus has an equation that is the area is 1/2 of diagonal 1 times diagonal 2. And both of the diagonals are 6 inches, 6 units, so this is going to be 1/2 times 6 times 6 for an area of 18 square units, whatever the units are. The second two ones come from trigonometry, and the equation that we use for that, for the area of a triangle, there's like about 20 different equations for areas of a triangle, and this one is 1/2, and we're going to do 2 of the sides, we'll call them A and B, and the sine of angle C, the angle that's in between the two of them. So in both of these cases, we would set that up. 1/2 8 times 12 times sine of 125, 39.3. And this one is going to be 1/2 6.4 times 5 times the sine of 85 for 15.9 square units. So we're now going to take a look at what are called inscribed angles and intercepted arcs. This guy is just full of definitions, okay? So the idea is that we have an inscribed angle, and an inscribed angle has a corner that is on the circle, and the two rays will cross the circle somewhere. So this angle here is inscribed, and then the arc that it cuts out is called the intercepted arc. We also can use the word subtend, so AC subtends angle B, or chord AC also subtends angle B. So these guys are inside those two inscribed angles. This is just the definitions of inscribed angles, intercepted arcs, and what subtend means. We have all three of those. So an inscribed angle is actually going to be half of the measured intercepted arc. Now, if we have the central angle and the arc are exactly the same size. So this arc is 60 degrees because the angle, the central angle, is 60 degrees. But if instead of going to the center, we go to somewhere on the circle, it doesn't matter where on the circle we go. We go all the way to the edge of the circle and back to the other side of the arc. That is now half, so that is 30 degrees. So just knowing that if it's a central angle, it's the same measure as the arc. If it's the inscribed angle, it's going to be half. So if I'm looking for the measure of angle T is right here, and it is an inscribed angle, and inscribed angles are half of the arc. This is the arc it intercepts, so we're going to do 48 divided by 2, so that arc is 24 degrees. I can also go the other way. I can find the arc. So we have another inscribed angle, and that inscribed angle is 50. The arc has to be double. So we can go both directions and find the arc by doubling it, or the angle by cutting the arc in half. So let's take a look at RS. arc RS and STR. So STR, we don't have any information on. So let's start by getting this arc right here. So we notice this angle is intercepted at angle U. So that means this has to be double the inscribed angle. Well, now look at R and S. Those are the endpoints for angle T. That means that angle T has to be, well, it's inscribed, it's half. So these two angles, which are both inscribed on the same arc, are congruent. It doesn't matter where we draw that angle. If it inscribes the arc, it is the same measure. So this is what this is saying here. So that is what this is saying here. These two angles, because they have the same endpoints, they intercept the same arc, they have to be equal angles, no matter where they are. I can even draw one that's super skinny. Hard to draw it there, but all of those angles all the way around have to be the same measure. So if this angle is 75 degrees, the blue angle here, the black one, it's on the same intercepted arc, so it also has to be 75 degrees. These are not big on calculations, guys. Double, half. So if we have this as 90 degrees, how big is this angle? Half, 45. These are not ones you're going to be doing a lot of calculations on. I've got the angle, I need the arc, double it, 76. And these both have the same endpoints, both of these angles are the same 72. This is called an inscribed polygon. All of the vertices lie on the circle. The circle is a circumscribed circle. So this is another vocabulary part of this. So we have an inscribed polygon. Every single corner has to be on the circle that circumscribes it. Well, when we have that, we have a couple different things that go on. First thing is this angle right here has its two ends on a diameter of the circle. Well, what is the semicircle measurement out here? It's 180 degrees. Well, how big's the inscribed angle? It's got to be half of that, isn't it? So that means this guy has to be a 90-degree angle. All inscribed arcs that inscribe a diameter have to be 90 degrees. The next one that we have is when we have a quadrilateral. Because of the way that they're inscribed, angle E and angle G are supplementary. Angle F and angle D are supplementary because this one, whatever this angle is that it inscribes, you've got to be half of it. Well, this one is the other side of the circle, so the opposite angles in a quadrilateral are supplementary. So how would we use those? Well, we see this dot here, and that's going to tell me this is definitely the diameter. That means this arc is 180. Half of that is 90. And we actually have an algebraic expression, so tiny little equation, and x has to be 45 degrees to make this work. This is a quadrilateral, and the two opposite ones have to be supplementary. So y is supplementary to 120, so that's going to be a 60-degree angle. And z is supplementary to the 80-degree angle, so that's 100 degrees. Not kidding, guys. We're not doing a lot of calculations on these. So if we want a camera to have a field of vision that is a 90-degree angle looking at the Statue of Liberty, where else could I stand? Well, I could stand anywhere on the half circle. And I'm going to be terrible at drawing this half circle, but if I stand anywhere on that half circle, I'm going to be able to see 90 degrees, the two corners of the Statue of Liberty. So this is another description type of problem, guys. Okay, a couple other types of questions. Now we know that angle X has to be 90 degrees because it inscribes a semicircle. So once I know that, then to find Y, add these two angles up, subtract from 180, and I get 50 degrees. Opposite angles have to be supplementary, so that means angle X is going to be 180 minus 82, so that's 98. And Y is going to be 180 minus 68, so that's going to be 112. This is a slightly more difficult problem. First off, what we know about these two opposite angles is they add to 180. So we have the equation 180 equals 10x plus 8x. So that's going to give me x is 10. And the other equation is going to be 180 equals c plus 2c minus 6. So that's going to be 186 divided by 3. Sorry, that's a c. So c is going to be 61 degrees. Go away. Okay, guys, that's the kind of stuff we're doing. Your homework will be posted on Google Classroom, and we can meet on Wednesday for any questions. Have a good day.